All right, welcome back everyone. Let's go ahead and look through the solution to the now you try problem for how to graph a quadratic function, a parabola, whose function can be factored with the greatest common factor. So the problem here states graph the following function, g of x equals 2x squared minus 6x by hand. We're going to find the vertex, the y-intercept, the y-intercept's mirror. Then we're going to find the x-intercepts by factoring out the GCF and applying the zero product principle. Finally, we're going to find an additional point along with its mirror and plot those as well. So let's go ahead and start with the vertex as is asked here. Let me just note the function g of x equals 2x squared minus 6x. We have an a value of 2, a b value of negative 6, and a c value of 0. So for this vertex, we want to use that little formula, negative b over 2a is the x value of the vertex. And in this case, we're going to get positive 6 over 2 times 2 is going to be 6 over 4 equals 3 over 2. So we still have a fraction, but that's not as bad as the one we did in the example at least. Let's find the y value of the vertex. We're going to plug that x value of the vertex back into the function to find its corresponding y value. So g of 3/2 is going to give us 2 times 3/2 squared minus 6 times 3/2. Go ahead and square 3/2 first to get 9 over 4, and then minus this is going to be 18 over 2. That 2 times 9 over 4, so I can reduce that to the 2 and the 4 to a 1 and a 2. So that this becomes 9 over 2 minus 18 over 2 equals negative 9/2. So we've got fractions, but they're just halves, so that's not nearly so bad as what we were running into in the last one. So let's see. Let's go ahead. And again, before I graph anything, let's find the y-intercept and its mirror real quick, and the x-intercepts at the very least. So for the y-intercept, we take g of 0, plug 0 in for x, and we'll get 0 out. So we have the point 0, 0, y-intercept. The mirror point is going to be, well, over the x value of the vertex. So the axis of symmetry is x equals 3/2, right? That vertical line. So if we have the y-intercept's mirror, it's going to have an x value that's straight on the other side of that. So that we, let's just draw this. I think that we've got enough information here. It'll be easier. It's easier to do pictorially than it is to try and write out a formula for this. Let's just go. Each grid line is 1/2. Seems to be simple enough for this. And then 2, 3 down here. 1, 2, 3 up here. Label my axes. Okay, cool. So x equals 3/2. That's going to be 1.5. Is 3/2. So here is our axis of symmetry. X equals 3/2. We can plot that y-intercept of 0, 0. And then to find its mirror point, I'll just take this from that point, 0, 0, to the axis of symmetry and double it, which is going to get us to the point 3, 0. And that looks like the other x-intercept as well. So let's check this by looking for the x-intercepts. We set y equal to 0. So I'll have 0 equals 2x squared minus 6x. I will factor out a 2x from this to get x minus 3. And this will give us that x equals 0 or x minus 3 equals 0. Solving the second one, we get x equals 3. So yes, indeed, we get the x-intercepts of 0, 0, and 3, 0. Cool. And now we can get that vertex point. The vertex is at 3/2, comma negative 9/2. So I'll go over here and say negative 1, 2, 3, 4, 5, 6, 7, 8, 9. It's down here, so I'm going to go and make this a little bit further down. 4, 5, negative 6. Negative 9/2 is negative 4.5. So that's this point. This is 3/2, comma negative 4.5 is the same thing as negative 9/2. We can see that this is an upward facing parabola, which makes sense. If I have a positive x squared, that's going to tell me that it's an upward facing parabola. It's definitely a helpful thing to be aware of. And then the problem does ask for 2 more points here. So let's plug in, let's just plug in 1. And yeah, let's just leave it at that. So if I do, you could have plugged in a different point, and that's also fine. I'm just choosing 1 here. I might do another one just to get a little more detail. So g of 1 equals 2 times 1 squared minus 6 times 1. And this is going to be 2 minus 6 equals negative 4. So I can draw that point in. And then its mirror point is going to be just right on the other side of that axis of symmetry at 2, negative 4. So I can draw in our parabola, at least to these x-intercepts. Now I don't really have any other points with positive y values at this right now, so I kind of want to add in a couple more points. So I think that it's going to make our graph really tall. Like if I did negative 1, it's going to end up being like way up here. I vaguely know that this graph is doing something like this, right? So I think I just want to plug in negative 1/2 and see what happens. So I'll have 2 times negative 1/2 squared minus 6 times negative 1/2. This will give us 2 times 1/4 plus, I'm just going to leave this as 6 over 2 because I'm looking ahead a little bit. This 2 over 4 is going to reduce to a 1 over 2. So I want to keep a common denominator, which is why I left that 6 over 2 here. So I get 1/2 plus 6/2 equals 7/2. And that is 3.5 also. So it'll help me plot that. So I'll go to negative 1/2, 3.5. Right there. And then I will go straight across the axis of symmetry to find its mirror point. We've got negative 1/2, 3.5. And then this looks like 3.5, 3.5. Okay. This, I can add some detail, draw my parabola up a bit taller. There we go. And I'll label this y equals g of x. And that wraps her up. We've got the vertex, the y-intercept's mirror. We've got x-intercepts, which we found because they were the y-intercept and its mirror already, but we also confirmed by factoring out the GCF and applying the zero product principle. Finally, we found an additional point along with its mirror, and we actually found a couple of additional points with both of their mirrors here, just to really fill this graph out nicely. So that's everything. Thank you so much for watching, everyone, and we will see you in the next one.